Hi, I'm Maria. I'm excited to visit the Atlantic Insight Lab today to learn how an advanced lubricants laboratory operates.
Hello Maria, welcome to Atlantic Inside Lab. Here we maintain the highest quality standards to ensure our engine oils are reliable, efficient and safe to use. Today I will be guiding you through our lab to show you the advanced equipment and technologies we use. Let's head inside.
Our lab is a fortress of precision, housing some of the world's most sophisticated tools like the FTIR spectrometer for molecular insights and the ICP for exact elemental breakdowns. But we don't stop with data. We interpret it, finding the hidden performance boosters and fine-tuning every formula to perfection. From wear resistance to thermal endurance, we uncover how each lubricant stands up to the ultimate test.
Usama, can you tell us what this machine does and why viscosity testing is so critical?
This is the viscosity bar by Canon. Viscosity measures how easily the oil flows at different temperatures, and it's one of the most important properties of the lubricating oils. If the viscosity is too low, the oil won't provide enough protection, and if it's too high, it can cause friction. We test viscosity at both 40 degrees C and 100 degrees C to ensure that our oil performs consistently under different conditions. This bar is maintained at precise temperature control so that we can get highly accurate readings.
We're now in the cold room where I assume you test the oils under low temperature conditions. Can you tell us about this machine?
This one is CCS, which is called Cold Cranking Simulator. It tests the oil's viscosity at low temperatures, ensuring it can flow even in cold weather. This test is crucial for the countries with the colder climates, where oil can thicken and reduce flow to the engine.
This equipment here is the calorimeter, correct? How does it help with quality control?
Yes, this is Lovibond colorimeter. It is used to measure the color of our oils. While it might seem minor, but color consistency is very important. If the color is off, it can indicate impurities or contamination that could affect oil performance. This one is foam stability tester, and it is crucial for us to test the foam stability. Excess foam in the engine oil can cause lubrication issues and it can damage the engine. With this apparatus, we measure the foam formed when air is introduced, helping us to create oils that resist foaming.
And here's our density meter. What role does this play in the lab?
Density is essential for understanding how thick or how thin the oil is, which affects its flow and overall performance. This machine measures density with very high precision, which is critical for ensuring each batch meets our standards. So by this machine, we are testing the fresh point of our oils to assess the fire hazard level associated with the oils.
I see some large machines here. What's the purpose of the setup?
This one is shear stability tester. This machine tests the oil's ability to maintain viscosity under mechanical stress, simulating the conditions it can face inside the engine.
Now, here's a really interesting device, the FTIR spectrometer. I've heard it's used for analyzing the molecular structure of the oil. Can you tell us more?
This equipment analyzes the oil's molecular structure while allowing us to detect any contaminants or inconsistencies. We can identify oxidation, water contamination, and even certain additives. It provides a fingerprint for each oil sample, helping us ensure uniformity across our batches.
Next, we have this sophisticated machine. It looks very high-tech. Can you explain what it does, Usama?
This is ICP, which is called Inductively Coupled Plasma Optical Emission Spectrometer by PerkinElmer. It's a powerful tool for detecting multiple elements within our oils, both used and unused. We use this equipment to identify any contaminants or unwanted elements that might have made their way into the oil.
And how exactly does it detect these elements?
Good question. It uses an ionized plasma as its light source, which excites atoms in the sample and causes them to emit light. And each element emits a unique wavelength, allowing us to detect and measure even trace amounts.
And what about this machine, the pour point tester?
It is essential for us to determine the lowest temperature at which the oil remains pourable. If the oil freezes, it won't reach all engine parts, leading to engine damage. This machine allows us to measure the pour point precisely so that we can ensure reliability in extremely cold conditions.
Usama, what is this machine? It looks like it's built for very precise measurements.
You are right. This is automatic potentiometric titrometer by Metron. It is used to measure the total base number and total acid number in our oils. TBN and TAN, both parameters gives us valuable information about the oil's condition and its ability to resist corrosion.
And why are these numbers important for engine oil?
High TBN means the oil can neutralize acids formed during the combustion process and can resist degradation, which is important for long-lasting protection. While 10, on the other hand, shows the acidic content. Too much acidity can lead to corrosion and wear.
I see a tester here for water separability. Why do we need to measure an oil's ability to separate from water?
This is the water separability tester by Kohler. It's crucial for us to test how well our oils can separate from water, because water contamination can severely affect performance. For example, in environments with high humidity or water exposure, water can mix with the oil, which could lead to corrosion, reduced lubrication, and even system failure.
Thank you, Usama, for taking us through each part of our quality control process. It's clear that every detail matters here at Atlantic Insight Lab. Thank you for joining us on this tour of Atlantic Insight Lab, where precision and technology come together to produce the highest quality engine oils. See you next time.